Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In this video, we will see another example on how Poisson distribution can adapt to change of intervals of time or space. Before we start, a small request. After watching the video, if you find it useful, then please like the video. Help your friends and other students who also are in need of such useful contents by sharing this video. If you are new to this channel or haven't subscribed to the channel yet, then please subscribe to the channel and press the notification bell. This will help the channel to grow and help you know each and every time about such useful videos as and when they get uploaded on this channel. So let's begin with this question. The question which we have taken is from May-June 2014, paper 73, question 7. What does the question say? A lost property office is open 7 days a week. It may be assumed that items are handed into the office randomly, singly, independently. So the event is handing of the items into the office, and the events occur how? They occur randomly, singly and independently. Then they are asking, state another condition for the number of items handed into to have a Poisson distribution. So what had we had learned? We had learned that for the number of occurrences of any event to follow a Poisson distribution, the event should follow certain conditions. What were the conditions? That the event should occur randomly, singly, independently, and should occur at a constant average rate. So another condition which we can give is, here I can say that the event, what is the event here? That the items are handed. So the items are handed to the office, handed into the office at a constant average rate. Okay, so all four conditions have been met here. 3 they have already given, and this is the fourth one. This answers the part first of the question. Let's go to the second part. It is now given that the number of items handed in per week. So here the time interval of time they have given is per week, follows a Poisson distribution with a mean value of 4.0 or 4. Then they are asking, find the probability that exactly two items are handed in on a particular day. So here the time interval they have given is for a week, but they are asking for a day. So let's try to define an interval, this one, a discrete random variable, and then we will change the interval also. Let's say let x be the number of items handed in one particular day, whichever day they choose. Okay, so x follows Poisson distribution with the parameter lambda. We have to find out that particular lambda. Here the lambda is not equal to 4. Okay, so let's try to find out that particular lambda. Let me make a table here, small table. So here interval I'll write in terms of days. and here we'll write down the mean number of items handed. Okay, so they said for 7 days the mean number of items handed to the office was 4. So if they are asking for 1 day, so that means they have reduced the time interval by 7 by 1/7. So I'll write down this also by 4/7, because we have studied that the events occur at a constant rate, so the mean basically is proportional to the interval. So what I can say here, lambda will be equal to 4/7. Now once we are done with this, then the question becomes very easy. They are asking find the probability that exactly 2 items are handed. So they are asking probability of x taking a value equal to 2. So that will be directly equal to e raised to minus lambda into lambda raised to r upon r factorial. So here what I'll get this as e raised to minus 4/7 into 4/7 raised to r is 2 here, upon 2 factorial. Okay, so if we solve this, what do we get? We get the value something as 0.092198 and so on, which we can write down as 0.0922 in 3 significant figures. Okay, so this answers the part 2 of the question. Let's go to part 3. What they are saying, find the probability that at least 4 items are handed in during a 10-day period. So now again they have changed the interval. So let's take a different letter alphabet for representing the discrete random variable for a 10-day period. So can I say let y be the number of items handed in during a 10-day period. During a 10-day period. So for that particular 10-day period, I will have to find out the lambda. So for 1 day, the mean is 4/7. So for 10 days, the mean will be what? 4/7 into 10. Correct? So that will be equal to 40/7. I'll bring this little bit down. And I'll increase this length. So this value will be equal to what? 40/7. So therefore, can I say y follows a Poisson distribution with the mean value of 40/7, where I can say lambda is 40/7. But they are asking for the probability of at least 4 items handed. So therefore, the probability of y is greater than or equal to 4. At least 4. So greater than or equal to 4 we need to find out. As we have studied in the previous videos as well, probability of y greater than or equal to 4, I can write it as 1 minus probability of y less than 4. Why I can write this way? Because we have studied that summation of probability of a random variable x taking a value r when r varies from 0 to infinity is equal to 1. Sum of all the probabilities for that particular random variable taking a particular value is always equal to 1. So from this, probability of y greater than or equal to 4 has to be equal to 1 minus probability of y less than 4. Why I am doing this? Because greater than or equal to 4 I can't find only, because it can be 4, 5, 6, 7, it can be anything. 4 or more than 4. Okay, so I can't find that particular practically. So what we do is we say 1 minus probability of y less than 4. So this is equal to what? 1 minus probability of x equal to y equal to 0 plus probability of y equal to 1 plus probability of y equal to 2 plus probability of y equal to 3. Okay, so let's try to find out this particular value. What I'll get this as 1 minus e raised to, I can take, because e raised to minus lambda is going to come common, so I'll directly write e raised to minus 40/7. I'll take outside the bracket as a common part. E raised to minus 40/7 inside the bracket. What I'll get lambda raised to 0, that is 40/7 raised to 0 upon 0 factorial, so that will be directly 1 plus 40/7 raised to 1 upon 1 factorial, so that will be directly 40/7. Correct? Yes or no? Then plus 40/7 the whole square divided by 2 factorial plus 40/7 the whole raised to 3 upon 3 factorial. So if I solve this particular whole thing and I subtract it from 1, what I'll get? In 3 significant figures, I can write it as 0.821. Okay, 0.821. This answers the part 3 of the question. Now let's go to the part 4. They are saying find the probability that during a certain week 5 items are handed in all together, but no items are handed in on the first day of the week. So no items are handed on the first day of the week, but 5 items are handed together. So that means those 5 items will be handed on the remaining 6 days of the week. Correct? So let's try to write down a variable for this. I don't have much space here, so I'll take another page. Okay, so can I say 5 items? This is part 4. 5 items handed in a week with no items handed on first day on the first day this means what? This means 5 items, no items on the first day, no items on the first day, and 5 items on remaining 6 days. Correct? Okay, so no items ended on the first day. So for one day, first day means one day. So for one day we already know the lambda. What lambda do we know? We know that the lambda is equal to 4/7. For one day the lambda is equal to 4/7, and I can take this x as the random variable for that particular one day. Okay, and for 6 day, what will be the lambda? For 6 day the lambda will be 4/7 into 6. Correct? So let's define a random variable for 6 days. Let's say we have already taken y, so let's take w. Let w be the number of items handed in 6 days. So therefore W will follow a Poisson distribution of 4 by 7 into 6, where lambda is 4 by 7 into 6, which is nothing but 24 by 7. Correct? So can I find this particular probability? Probability of W equal to 5. That means 5 items are handed on the remaining 6 days. So this particular value will be equal to what? It will be equal to e raised to minus lambda, that is e raised to minus 24 by 7 into 24 by 7 raised to 5 upon 5 factorial. Correct? And we already know that x was the random variable which represented the number of items handed on one day. So we also know that probability of x is equal to 0 will be equal to what? Probability of x is equal to 0 will be, bring this little bit down, will be equal to e raised to minus 4 by 7. Why here 4 by 7, why not 24 by 7? Because 4 by 7 is the parameter for one day, mean value for one day. Okay, into 4 by 7 raised to 0 upon 0 factorial. Correct? So this is one value we got, this is another value we got. Correct? Now they are asking 5 items handed in a week with no items handed on the first day. So that means they are asking probability of W intersection X. Correct? And means here intersection, but W and X, they are independent of themselves. So can I say probability of W intersection X will be probability of W into probability of X? Correct? So what values we will get here? I can put this particular value here, whatever we have found. I can bring this down here, and I can bring this down here. So I can multiply both the values, and if I multiply both the values, what is the final answer we will get? After calculating, the final answer will be 0.0723 in 3SF. So here they involved probability of statistics 1 also, where intersection is involved. Okay, but the events W and X, they are independent among themselves. Okay, that's the reason this intersection gets converted into multiplication. Okay, so this ends with the part of question 4, and this ends with the particular question also. So if you have enjoyed the video, please like the video, help your friends and other students who are also in need of such useful contents by sharing this video. If you are new to this channel or haven't subscribed to the channel yet, then please subscribe to the channel and press the notification bell. This will help the channel grow and help you know each and every time about such useful contents as and when they get uploaded. Please comment what was good, what can be improved. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.